the area enclosed. Mathematicians are weird. It's the moral of the story. That is usually the reaction I get from a class. The only way that joke only starts getting laughs in like upper level math classes. It gets just rounds of laughter in a higher level math class. But if you tell it to anything like below calculus, people are just like, it's not a joke. I will not accept that as a joke. And I respect that. That's fine. I'll try to find less nerdy jokes. Let's see here. Where are we? We end at 3, right? Oh, 240. Oh. All right, I'm going to move on to the next. I think that gives you a pretty good feeling for the word problems that are in that section. Let's look at something from 1.4. So I may be getting ahead a little bit, but I think that's okay. Let's see here. So we're supposed to. Here's the question. So we're. Goodness gracious. Let's consider x minus 2 greater than or equal to, say, 10. All right. Then the question is, whether or not a given list of numbers are actually solutions. We're basically asking, let me see here, is x equals to 8 a solution to the inequality above? So how would you, I've talked about what an equation is, right? But this is not an equation, right? This is an inequality. Why? An inequality is when we have two expressions, right? And they're related by some inequality. So this is an inequality. Solutions to inequalities are also sets of numbers which make the inequality true. So to ask whether or not 8 is a solution to an inequality is asking, if we plug it in, does it work? Does it? No, it does not, right? Because 8 minus 2 is 6, and 6 is not greater than 10, right? So 8, not solution. How can we find the solution set to an inequality? Or in other words, how do we solve an inequality? Let's solve that one. What should we do? So really, I'm asking you, what can we do to inequalities to change them to simpler inequalities where like the solution's immediately obvious? So we still have an addition principle, and we still actually have a subtraction. Like we can add to an inequality, we can subtract from an inequality, but multiplication gets trickier. I'll show you in a second. But that's not going to be an issue here. So let's add 2 to both sides of the inequality. What's that give us? And something I haven't been doing enough in here yet, but when I get tired of writing something, what I'll do is I'll give something a label. So I like to underline it and call it star. And so I can say add 2 to star. And that gives me a way of making sure everyone understands what I'm doing. You say, well, how could anyone not understand what you're doing? Fair enough. I mean, there's only one thing to do here. But when you got like multiple things running around, it's helpful to have this like labeling system in your mind. Anyway, so added 2 to star. What's it give us? What's that? X greater than or equal to what? 12. All right. And so can you do better than that? I mean, not really. That's pretty much the solution. But what if we wanted to write the solution as an interval notation? Have I talked about interval notation with you guys yet? I don't think so. So this it's the people trying to sell me an extended warranty on my van. I know it's a 919 number. I don't know anyone I talk to there, but they're like always trying to sell me an extended warranty on my van. But my vans are not worth an extended warranty, you know? So actually, they always tell me we're trying to renew your extended warranty, which is just nonsense because I never bought one, which is how I know not to talk to them. But anyway, so interval notation, there's 2 other ways to express this, right? So the solution set in, so you could, solution set would be this, x such that x is greater than or equal to 12. This is the solution set to the inequality. And another way you could write this would just be like you include 12 and you go all the way to infinity. These are the same thing. That's the interval notation for the solution, interval notation. But the thing we might do more in here, I suspect, is this. So we draw a little dot, and like this. So so we can envision x being like here somewhere. X is to the right of 12 on the number line. That's the solution to this inequality. Okay? Now, I should warn you, we've got to be careful with inequalities. Let me do one more here. This will probably be it for today, but so just here's like a general, let me be somewhat unscientific about this. Stuff is less than or equal to Bob. That implies that A times stuff is less than or equal to A times Bob. But provided what? Provided that this number A is positive. However, it implies that A times stuff is greater than or equal to A times Bob if A is less than 0. So the basic principle here is multiplying by a negative number flips the inequality. So example, if I wanted to solve minus 3x less than or equal to, 6, then I can divide by 3. I can multiply by, I can either, let's say I'll divide by minus 3. So dividing by minus 3 is what? Is same as doing what? Multiplying by what? Minus 1/3. So minus 1/3 times minus 3x is greater than or equal to minus 1/3 times 6. We have to be careful. If we multiply the inequality by a negative number, it turns it over. And so the solution here would be x greater than or equal to minus 2. And we could write the solution like that, right? You could also write it in interval notation. This would be what? This would be the solution set, minus 2 to infinity. Does that make sense, why the minus turns the inequality over? I mean, I could look at something simpler just to convince you, maybe. Suppose x is less than 4. You know, multiply by minus 1. So, for example, 3 is less than 4, right? 3 is less than 4. That's a particular example. Is it true that minus 3 is less than minus 4? So that's the kind of thing that's in that just-in-time review assignment with the 60 questions. It's got stuff like this in there. But this is bad. He's forbidden. I mean, it's not true. If we draw the number line, minus 4 is over here, minus 3 is there, you know? So we got to be careful about which one's smaller when we deal with negative numbers. It's somewhat non-intuitive if you're not watching out for it. Anyway, I'll stop there, and I hopefully see you guys next Monday. I won't be here Friday. I have to go out of town. My father is sort of near death. We're not sure exactly, and I should be there. So my mom's just brought him home from the nursing home. She hadn't seen him for 5 months because of the COVID, you know, and so he's at peace. I need to be there, so I won't be here Friday. Thanks, guys. Hold on a second.